The next piece of the number E is, what does it look like when I graph it? And the nice thing is it's going to look really similar to the graphs that you did yesterday with just regular exponential growth or decay. That's what's going to happen. They are growth models or decay models. The way that we tell which it is, whether it's growth or decay, is to actually look at the exponent. So if we look at our exponent, if the number in front of x is positive, then it's going to be a growth, and it's going to look like this. It's going to be going up very quickly. If the number in front of the x is negative, then it's going to be a decay or declining very quickly. My domain is still going to be all real numbers, no matter if it's growth or decay. I can put any number in. It's going to extend both directions, left and right, forever. My range is going to be above the x-axis. So my range is going to be everything where y is greater than 0. What ends up happening is you have an asymptote that's going to happen right along the x-axis. And your graph's going to look a lot like this. So it's going to get really, really close to that asymptote, but not touch it. And then finally, your y-intercept, you can find one of two ways. You can just plug 0 in for x, or you can realize that it will just be your coefficient. And we always write it as 0, comma a. So wherever that place is, where it crosses the y-axis, is going to be that 0a point. And this is going to be true for all of our graphs that we're looking at. So we're going to look at a couple really basic ones that will help you with your work in Delta Math. So this one wants to graph 2e to the 0.75x. So on your calculator, just to kind of show you how to do this on the calculator, you're going to go to y equals. You're going to type in 2, and then you're going to use that e button, so second, and the ln button. And your exponent is 0.75x. And then you're just going to hit graph. And a lot of times you don't see a lot of the graph because it kind of merges into that axis. That's where that asymptote is. The y-intercept is going to be at 2, so you're going to put a point at 2 on the y-axis. And then you're going to draw something that goes up through that point and then grows very rapidly. Notice that it never actually touches the x-axis. That's where that asymptote is. My domain, again, is all real numbers. And my range is going to be everything that is above the x-axis. So you could write it as 0, y is greater than 0, or you could write it as 0 to infinity, because it's everything in this upper part of the coordinate plane. For this one, we're going to go to our calculator, and we're going to go to y equals and type in 1/2, and then my e button, 3x, and hit graph. This time it's still a growth graph. This time my y-intercept is actually going to be at 1/2, so it's going to be kind of hard to see on this picture, but I'm going to try to put a little point here. It's going to be right here. My graph is going to go through that point and then escalate really quickly. It's going to get really close to the y-axis, or to the x-axis. My domain is going to be everything, all real numbers, because it goes forever left and right. My range is going to be everything greater than 0, or again, you can write it as 0 to infinity. And my y-intercept is 0/2. So you should be able to, on Delta Math, tell me if it's growth or decay. You should be able to tell me where the intercept is, and you should be able to tell me the domain and range. And I'm going to put a couple of those like that. And that is the graphing piece.